Today we're going to talk about how we solve systems by substitution method. So last section we talked about how to show them graphically. Now we're going to talk about how to solve them in the substitution method. So this is more of the algebraic way of doing things. We're not going to use a graph in any way whatsoever. We're actually going to use our setting up an equation and solving for an equation, probably with variables on both sides. So step one. We're going to solve one equation for either x or y. Remember, that means one of the equations we're going to get x equals and put everything on the other side, or y equals and put everything on the other side. Remember, solving an equation means get that variable by itself. So step two, what we're going to do is we're going to plug that number into the other equation for that variable. So what we're going to do is we're going to push everything onto one side and take that expression and plug it in for either the x or the y of the other one. This basically means we're going to remove the x equals or the y equals, whichever one we solve for, and take the expression on the opposite side and plug it in replace of the x or the y from the first equation. So now we will have an equation that has all the same variable. So what we do at this point for step 3 is solve for that remaining variable. Step 4, once we have the variable that we solve for, what we're going to do is take that number, so we should have a number at this point, and plug it back into the other variable to find the other variable we're looking for. So, probably sounds kind of confusing right now. It's a little bit confusing until you try it a few times. So let's see how it works in an actual system. And I think what you'll find is with a little bit of practice and kind of following the steps, you should be okay on how to do this. So here we have an example. We have a system with two different equations in them. So in the first step we saw, it says solve one equation for either x's or y's. Well, you should notice that this first equation is already solved for y's. So I don't really need to do any solving. When I look at this one, though, next step says plug that into the other equation. So basically what we're going to do is look at y equals 2x minus 4, and we're basically going to say, well, if y equals 2x minus 4, I can take this part of this equation and basically plug it in right here to where the y's are. So what that's going to look like is the following. The second equation is going to look like this, where in place of the y that we had in the original equation, we're now going to plug this 2x minus 4 in. So we basically are taking y out of the second equation and replacing it with what we said y was equal to. So kind of like when you are plugging in and solving an equation where somebody says y's are 7, and you replace the y with a 7 and you keep going. It's the same idea, except we're putting an expression, not just a number. But at this point, what you're going to notice for step 3 is we can solve now for one variable because there's only x's left over. So this is where we would then move on to say, use your your equation solving. I'm going to use my distributive property to get negative 4x, and then plus 8 to break up that group on the left-hand side. I can combine some like terms here to get 3x plus 8 equals 5. I would then subtract 8 from both sides with my SADMEP steps, making sure that we're keeping our negative there to make sure we don't lose that. And we get 3x equals 3, negative 3. Divide both sides by 3. X equals negative 1. So that is step 3, solving for the variable that's there. So a solution, as we saw in the last section, is not just the x value, it's not just the y value, it's both. So we need to have the x and the y. So at this point, what I need to do is go back to my first equation, now the other equation, which is y equals 2x minus 4. I now have the x value. So what I'm going to do is plug in the x that we just found, which is a -1, into the x's for that equation. So at this point, all I have to do is use 2 times -1, which is -2, and subtract 4. I get a -6 for the y value. So the solution to this problem and this system, and again, it needs to be an xy coordinate, is going to be -1, comma, -6. So definitely some steps, definitely some things we have to make sure we keep ourselves organized with, but definitely something that we should be able to follow. In some ways it's easier than graphing because now we're going to get exact answers versus maybe trying to approximate some things on the graph. But the substitution method is one of the methods that you will use quite a bit. So here in example 2, we had the same idea that we talked about in our last section. It's a little bit more of a challenge to kind of get our systems out of word problems. So we'll kind of talk through this one a little bit. We have the little number boxes here to help a little bit as well, but just to kind of talk through it. So looking at our information, so we have a total of 50 veggie and turkey burgers, okay? And we purchased $90 worth, so that's something to keep in mind. So even though it's in that first sentence, though, it's really not part of that. The first sentence is basically telling me the number of burgers. So I could have 0 of one and 50 of the other. I could have 1 of one and 49 of the other. I could have 25 of both. That's what that first little phrase is telling me. The second sentence actually goes with that $90, and it talks about $2 per turkey burger and $1.50 per veggie burger, and when I put those together, I spent $90. So that's going to kind of try to be the second part, which is dealing with a cost more than it is the number of burgers. It's also defining our variables for us. The turkey burgers are the x's, and our y's are the veggie burgers. So down here we have kind of the little verbal models to see how that works. The first one we were just referring to, the number of turkey burgers plus the number of veggie burgers equals 50. And again, we're not really sure how much of each. We know they add up to 50. So that by itself is not enough information. The second one, when I look at the turkey burgers, $2 for each burger times the number of them plus $1.50 for the veggie burgers times the number of them. If I add those together, I know I spent $90. So that's basically our system. So we want to look at here is how do we get the numbers to work out? Okay, so I think if I look at these two equations, the first one looks a little bit easier to get into y equals or x equals. So let me just bring this one over here. X plus y equals 50. So the first step says solve one equation for one of the variables. So this is step 1. I'm going to solve the first one for x. No real reason. You could certainly do the other one for y. That's fine. But the first equation is just 50 minus y, where the x equals 50 minus y. So then step 2. Step 2 says take this piece of that equation, the x equals off, and replace that into the second equation. So if I look at the second equation, remember the second equation looks like this. So I'm going to replace the x's with 50 minus y. Now I'm going to use my third step to solve for the y's because I see only y's left. So step 3, use my distributive property here. I get 100 minus 2y plus 1.5y equals 90. I get 100. Negative 2y plus 1.5y is negative 0.5y equals 90. Remember, I'm solving for y's, so I need to get that by itself. So my first move here is to subtract the 100. Remember, the sign out in the front tells me that we're adding 100, so I subtract 100. So I have negative 0.5 y's equals negative 10. When I divide by negative 0.5, y's equals 20. So then step 4 is going to say, now take that number and plug it into the other equation. Well, we're just working in the 2x plus 1.5y equals 90. So I go back into the other equation, and now I replace the y's with a 20. Once I subtract 20, I now know that x equals 30. So for a solution, what we have here, based on all this information, is we have our solution 20 of the veggie burgers and 30 of the turkey burgers. And that's how you would use the substitution method. Certainly one that will take a little bit of practice, but it is a good one to make sure we have and understand. We'll be using it an awful lot throughout this year and certainly next year.